let's look at one of these circuits on an actual breadboard. The circuit we'll start with is the simplest circuit we could think about so far. We have a battery with an EMF E, which comes down to a single resistor and then closes the loop. So in our physical setup that we're about to look at, this will be 9 volts. And our resistor R will be 2.2 kilo ohms. And we know that current is going to flow through the circuit. And if we do the calculation, then V equals IR, so the current is going to be 9 volts over 2.2 kilo ohms, which if you work it out, it's about 4.1 milliamps. So let's see how you do that. If you were taking this course in an on-campus class, there would probably be a lab component, and you might have to build the circuit on a little proto board, kind of like this. So I've described these before a little bit. I showed you how all the whole pattern works. So on a board like this, you'll see these at the top. These are where your power comes from and your ground. So the red ones usually have a few different options of 5 volts or 12 volts or 9 volts, whatever it says down here. So right now this one is hooked up to 9 volts and this one is the ground. They're really on either side of a battery. The long strips like this are all connected. So when I take a wire and go from the ground and put it in this group of 5, these strips actually goes all the way down. So this little row, the right side here that I've defined, that is all going to be ground. I've done the same thing with the high side, the 9 volt side. So if you go all the way down this, then this is all 9 volts. So to avoid having to put our resistor directly on those two, I'm going to put a jumper. So you can just take a wire. Here I'm just using blue, and I'm going to have it jump from here. I can go here, that's connected to the ground, and just go to some row. These individual rows are connected, but only the 5 rows are connected here along this way. Here it's the whole thing. So I'll put a jumper for the ground side, and I'll put a jumper for the 9 volt side, like that. And then to complete the circuit, we just need the resistor. So here's a resistor, and if you follow the color code, you'll see that this is a 2.2 kilo ohm resistor. We'll post the color code somewhere on the site rather than do a lecture about it. So what I'm going to do is have one leg go in the same row of 5 as that jumper, and that makes it connected on this side to the resistor, like that, and that goes in, and then have the other leg go in this row of 5. And then the resistor is connected. So that's the circuit. So hopefully you can see it's not too far from the board. On the board we have the 2 ends of the battery are here, and then it goes to the resistor is over here. Now let's wait, let's check and see if it worked. So one thing we can check is with a multimeter. So the multimeter, you have to have the things plugged into the voltage and the ground side, and you take your 2 leads and you turn it on DC volts, and we'll see we should have 9 volts across the resistor, and sure enough 9.12 volts across the resistor. So when you measure the voltage on a circuit, remember you're measuring a potential difference. And that's why you don't have to do anything to the circuit. You just touch it in 2 places. I'm measuring the difference between here and here. So you directly measure the voltage that way across the resistor. You also want to measure the current. So we calculated that the current would be about 4.1 milliamps. So you got to do a couple things for that. First, you usually have to switch your multimeter. They often have a different input. And then this one screams at you because you're hooked into the milliamps, but you're on volts. So we're also going to turn it over to milliamps. All right? So now your leads will measure current, but current is not a difference. Current is a flow of charge across an area through a wire. So to measure current, you have to break the circuit. We have to make the flow of the current actually go through the instrument. So it has to go in one lead, out the other lead. The only way to do that is to break the circuit. So I'm going to break it here. I'm going to pull this out and stick it in here. Now it's in a different row of 5. And I'm going to then complete the circuit by putting the red lead here on this side of the resistor and this lead on right here. I'm going to touch that jumper right there. And there you go. You can see the current measurement, 4.2 milliamps. We calculated 4.1. The resistors are only good to about 5% anyway. So that's definitely close enough. So that's the basics. I wanted to show you the simplest possible circuit and describe a little bit about how on a real proto board you measure voltages and currents. Now we'll later move on to more complicated circuits.